Thank you, Praveen, for arranging this event. I think it's a lot of effort to arrange this event and all the distinguished guests who have taken a time to attend this event. We have talked about a lot about safety and the material science and combating the corrosion. So I'll give you about history of Alleima. It's earlier called as a Sandvik company. So we have a history of 160-year-old company. We believe in innovation and we have a lot of recipes to manufacture the materials which can combat the corrosion. Of course, you cannot avoid the corrosion. It is impossible, hardly impossible to avoid the corrosion. But yes, you can delay the corrosion. You can give a life to the heat exchanger. You can give a life to the reactor. How we will see by the manufacturing process. Of course, safety is the first, as Mr. Raja told, because all across the globe, when we go, safety is the first prime important for us as an employee, as a customer, and as our supplier. So all the safety aspects you have seen in this presentation, but I'll touch upon only two safety aspects which are new. We are following up from last 2 to 3 years. One is a psychological safety. It is not talked about a lot within India, but when, as a global company, we talk a lot about psychological safety. It is very important aspect when look at me, when I wanted to give any suggestion around the safety, whether I am psychologically safe to speak up. This is interconnected with this. If you go to any organization, the person who is operating or who is a contractor, he knows his machine. He knows what is going wrong on the machine. Are we allowing him to speak up? How he will speak up? If he is psychologically safe, his suggestions or his inputs are considered, then he will speak and you will take a one step toward the safety. This is how we look at globally. So we are not only a product supplier, but also solution provider. So we have an advanced tube manufacturing facility within India and across the globe. So I'll give you about the company. As I told, this is a very old company, 160-year-old company. How we survived so many years because of innovation, because of the culture what we have. And in 31st August 2022, we become as a new brand Alleima. How this word invented is the symbol A, which pushes the line. It says that the crossing the boundaries, and then Allais is the ancient French name, which is called as alloy, and MA means material. So this is the history of the company. So we have started in 1862 in Sweden, and we keep on going on inventing newer and newer alloys, and by 2022 we have become independent. Some of the highlights are like seamless tubes we have started producing in 1880, and the 1985 we have invented duplex alloy. This is the biggest innovation what we did. There are two alloys which can, two phases, ferrite and austenite, which is mixed together, become a one different material called as duplex. So that is invention of us. And then so on, we are going on inventing like duplex, then super duplex, then hyper duplex, and hyper duplex. This demanding invention came from the industry. The requirement came from the industry, and researcher and our R&D people have taken this as a challenge to develop new and new alloys. And some of the brands what we are holding is a Kanthal, which is related to heating materials. So any furnaces or any heating material required for heating, resistance alloys we manufacture. And then we have some medical companies also acquired in other part of the world. So we have our base is from Sweden. We have 90 sales offices, 4 R&D centers. We have operation in 40 plus sales offices and 27 production sites across the globe. Sustainable steel. Sustainability is very important for us when you look at the environment. So 80% of our material is recycled. So when I say recycled, you take a lot of efforts to refine the material. And you need to put a lot of production cost to refine the material. But it is important to give something for the next generation. So this is how this challenge we have taken. Also, in Sweden, we have a 100% fossil-free energy consumption company. And our aim is to go up to, by 2030, by 83%. Again, from here, adding 1% is a challenge. So maybe Paresh knows that adding 1% of refined steel, the used steel, to make reusable steel is biggest challenge. So then we have the tubular solution, which is a bigger chunk of our revenue. Then we sell bars also. Then again, a heating system, as I told you. We have a precision strip product, which one of the slide you have seen a flapper wall, which you're sitting here or home, wherever your refrigerator or AC is, which comes of 5-star rating. Then it depends upon the flapper wall. How many times the flapper wall opens and closes within a second, that decides. So we have the material which opens 35% more. That means the intake to the compressor is more, exit to the compressor more. That AC will give the effect on same duration time. So that product we manufacture. Then we have the medical wires and then coated strips. This coated strips is the new product invented by us, which is used for hydrogen vehicles and the hydrogen energy transformation where we have developed. We are seeing the percentage is less, but we estimate this will grow in double digit in near future. So we are there in all the industry sectors, right from the refinery, industrial chemical, specialty chemical, oil and gas, then heating materials, then you can consumer product, like for example, if you are using Gillette, the steel what is used by Gillette is manufactured by us, because we have invented so many years and we have changed the recipe to give the more and more shaves, number of shaves, because we have added certain elements to give the age retention property, which is required for that material. And some or the other way we are touching your life from the day you start. So then we have into the power. Nuclear is the biggest sector for us. We supply a steam generator tubing in nuclear sector. Then we are into mining sector. The air industry is also biggest industry for hydraulic and instrumentation tubing, where we supply titanium tubes. Medical is another industry where we have a wire developed for cochlear implant, and it is invented 10 years back, and we hold the patent. We have a tie-up with Australian company. So those across the world who born in deaf, they can hear because of the wire what we produced, because we have added certain element which gives the vibration and then convert into the sounds. And then hydrogen technology. So we are the material inventor. Our core is invention. So if you see, we have a 900 recipes, 850 patents. We hold highest number of patents. Then 230 people across the world work in R&D. And 1.5% of our revenue goes into the R&D to develop new alloys. And some of the invention I have shown, some will touch upon. The one which you see is the next generation FlexiFlex walls. Again, it opens more, so you'll consume less energy. And then Sanicro 35. And one of my colleagues will talk about that. So we have a fully integrated value chain. So when I talk about fully integrated value chain means we melt our own alloy. We're not buying anything from market. And our development starts from the innovation. So we have a tie-up with many licensors. They come to us if they wanted to change any pressure, temperature, or chemical composition. Then they throw a challenge to our R&D. This is what we wanted to develop, and then we tie up with them and we develop alloys. Certain tests are going long, and then we have an industry partnership also with the universities to take help of them. And then we have our in-house R&D facility and a lot of the equipments, what we can do a trial along with some of the customer as well as some of the licensor to develop a new alloys. And then we go for the melting of that alloy, then hot working, cold working, finishing, and the last comes is the sales. I stand last. So R&D stands first for our company. So I will give you a glimpse about how tube is going to manufacture, how tube is manufactured. This is of course a visual, but you will get a fair idea right from melting to the finishing how tube is manufactured.
At Alleima, manufacturing is based on recycled steel and purchased alloy materials. We buy high-quality scrap only from certified suppliers. The raw material is analyzed and any harmful ingredients are carefully removed. The scrap is melted at 1,600 degrees Celsius in an electric arc furnace. In the argon-oxygen decarburization vessel, carbon content is reduced to stainless steel levels. Exhaust gases from the furnaces and AOD processes are filtered to cut pollution, and the dust extracted is further processed for metal recovery. The chemical composition of the melt is closely monitored throughout the process to meet our own demanding standards. We make continuous analysis to guarantee the correct steel grade and ensure traceability and consistency between the batches. The results are entered in a form that accompanies each batch at every stage of the process. After pre-rolling of continuous cast material or ingots in the blooming mill, billets are transported to a heating furnace to be reheated to the correct rolling temperature. The billets are then rolled in Alleima's modern rolling mill, where round and square billets are rolled to a wide variety of sizes. The new mill provides quick product dimension changeover, short lead times, energy savings, and excellent product quality. The mill is integrated with the blooming mill to form one continuous production line. Billets and bars are rolled to finished size in 1 to 6 passes, and cut into requested lengths. The bars are inspected before dispatch or put through further internal processing. Full traceability is maintained throughout the manufacturing process. Before the bar steel is used for tube manufacturing, its chemical composition is confirmed in a spectrometer test. To prepare extrusion billets, the bars are peel-turned, cut, and deep bored. The extrusion billet is heated to about 1,200 degrees Celsius. And then lubricated internally as well as externally with a glass powder. A mandrel is inserted into the hole in the billet. When extrusion begins, the billet is pressed out between the die and the mandrel, resulting in a seamless tube that can be delivered directly without further processing through cold working, according to customer specifications, or used as the starting point for further processing. The extruded tubes are rapidly straightened and pickled in acid to remove glass and metal oxides. After deburring, dimensional checking, and inspection, the tubes are ready for final production. Following visual inspection and X-ray spectrometry, the tubes pass through the pilger mills to re-establish material structure and hardness. The tubes are then heat-treated in an annealing process. They are heated to over 1,000 degrees Celsius in a protective atmosphere to prevent oxidation. and then rapidly cooled to about 300 degrees Celsius. The tubes are straightened, polished, and thoroughly cleaned. According to customers' requirements, the tubes are fully inspected for defects using ultrasonic and eddy current testing methods set to detect the tiniest defects such as cracks, cavities, or other material defects that the naked eye can't detect. Their dimensions are verified and they are also checked to ensure they are free of intermetallic phases. This is followed by visual inspection. The destructive testing stage includes flaring, flattening, and tensile strength tests. Corrosion and microstructure properties are also verified. Such tests are crucial to ensure the material meets customer specifications. The tubes are stored in Alleima's fully automatic stockroom, from where they are eventually selected, packed, and loaded onto trucks for further distribution to their final destination. The tubes are delivered together with complete documentation. Alleima has now fulfilled its commitment to deliver stainless steel tubes of superior quality.
Well, that is all about the tube manufacturing process, and everywhere across the globe we follow the same process. And all the manufacturing plant, we have a standard quality system which is monitored by Sweden R&D and quality system. And here we have plant in India also have to go with the audit procedure, which is the internal and external audit. And we give a lot of thrust on automation and digitalization when it comes for the plant operation. So you have seen the manufacturing process. What we manufacture the tubes, we have of course integrated manufacturing facility right from melting to tube manufacturing production. But there are, if you buy a tube, there are two universal method. One is a hot working and cold working. What you buy for heat exchanger is a cold work tubes. In hot working, there are two methodologies to manufacture hot worked pipe. One is a hot extrusion, what we follow, and another method is the hot piercing method. Hot piercing is an old method, hot extrusion is a newer version of it, how it improves the quality. So this is the latest technology, and any material if you take, the last portion which gets solidifies the center. And all the impurities which will be get segregated at the center, and it is called as the impurity, and we need to improve that impurity. During the hot extrusion process, we remove the core of the bar. It helps to remove the impurities. Also, it helps for ease of hot extrusion. So major operation is to remove the impurities from the center of the tube. Also, it has a compression force in it. And you'll get an uniform thickness all across the tube. Then second method comes is a hot piercing method, whereas you don't remove the impurities of the tube. It is a carbon plug which is used for creating the hole, I can say. And this carbon plug used number of times, many times they use if they don't have a process. And then there are 4 pressure roller mill where it puts a lot of compressive stresses on the tube, which leads to the stresses in the tube if you are not done well heat treatment. Apart from that, the impurities from the center are not removed. When you create a hole, that impurity goes to the ID side of the tube. And when you have selected a right material, you have selected everything right, but you are buying, let's say, assume 6 meter tube or 4 meter tube, and you're buying, let's say, 500 tubes. You never know which tube is having this kind of a issue. Once it fails, you start investigating what has gone wrong. It is not gone wrong. You have to buy a right method manufactured tube, you will get a right product. So this is a small video where we creating the hole before we go for hot extrusion. So in this process, we ensure that the impurities are removed from the center of the bar. And then also we use the lubrication, which is the unique lubrication what we follow for, it is a glass lubrication. We make sure that the metal to metal contact is avoided all the time when tubes are manufactured. Whereas if you see hot piercing, there are a lot of metal to metal contact happens when tubes are getting manufactured. So this is exactly a hot extrusion process. So the hollow is ID and OD both side lubricated by glass lubrication. And this becomes we call it as mother hollow or mother pipe, which is used for manufacturing heat exchanger tube. Yes. Then we use a 9-step cleaning process. This is very important when tubes are produced. I have one video in the next slides where you will see which are the nine methods we use for cleaning the tube. Then here comes is the application which is called as umbilical tubing. It is very challenging application where the testing requirement is as good as or slightly more than nuclear tubes, because these tubes go subsea to extract the oil from the well. And we are the leader in supplying these tubes. And just to give the figure, by 2024, we have supplied the tubes which will require, to give you an idea, it is 3 times if you wound the earth. That much of tubes we have supplied, 99% on time and with 0 failure and no defects, because defects are not allowed in this, because if that well offs, then $1 million losses are there. So we are keep on inventing on this, and this is still a major application for us. Then as told by us that we are now manufacturing within India as a Make in India. So all the technology is transferred to India from Sweden, and we have a local presence within India in Mehsana. So we manufacture grades. This is our capability for hot finished pipes. We manufacture from 65 mm tube to the length of 15 meter, whereas cold finish heat exchanger tube we manufacture 30 meter length. And from 12.7 to 50.8 OD tubes, and cold finish tubes like hydraulic and instrumentation tubing, 6 mm to 16 meter. Apart from that, we manufacture all alloys like titanium, zirconium, bimetallic tubes where zirconium is inside, stainless steel is outside, composite tubes, carbon steel is outside, and the high nickel alloy tubes inside. These technological tubes are manufactured in Sweden, not in India, because you need a lot of investment and furnaces for that. But yes, these kind of tubes also manufactured within our portfolio. We also manufacture medical tubes. Tubes with having 1 mm OD, still is having hole, used for medical application, manufactured in Sweden. These are the alloys, apart from stainless steel and duplex, we manufacture within India. All days it was imported from Sweden. So we are now started manufacturing in India and supplying to specialty chemical and some of the pharma companies from India. So all the nickel alloys and C22, C276, Sanicro 28, SAN 35, all the nickel portfolio, including nickel 200 tubes manufactured within India. Why we have done this? Because as you see, the industry is growing very fast, and the supply chain is one of the critical criteria. You need a delivery is faster with the quality tubes. So we have started, we are qualifying this grade from last 5 years and supplying the tube here within India market, within Asia market, but also across the globe we are exporting from here. So hydraulic and instrumentation tubing, these are used, of course, for your complexes, and we do an energy audit for you. We have partners who do an energy audit and give you a report. So from which location the leakages are happening, how much leakages are there per hour, per month, and per year, how much losses, because these are non-accounted losses, because this is the last portion where you are neglecting the losses, because that doesn't contribute to your, but these are big losses. When you do an energy audit, you will come to know there is a possibility of saving here. Wise.
Every day, industry relies on hydraulic and instrumentation tubing to secure safe, trouble-free operation of key equipment and systems. From renewables to petrochemicals to high-pressure compressed natural gas, there's no room for unscheduled downtime due to leaking valves or fittings, which could cause a system failure. In complex systems, tube makes up less than 5% of the total costs, but shortcuts on quality can lead to much higher costs in the end. So to avoid risks and gain peace of mind, it really pays to use premium quality seamless tubing from Alleima. But admittedly, it's not easy to see the difference between Tube A and Tube B. Tube A here is a high-quality grade from Alleima, produced with 83% recycled steel in a sustainable process refined over 160 years. But even Tube A can get lost in the mix, since many grades meet the standards for ASTM, ASME, ISO, and so on, even if only barely. At Alleima, we don't settle for good enough. We always strive to set the standard within the standard to make sure you get the highest quality. It all starts with our in-house melt in Sandviken, Sweden, where we can control and optimize the chemical composition to deliver properties like higher corrosion resistance. Here, you can see how Alleima 3R60 tube, for example, offers superior corrosion resistance compared to the standard 316 or 316L grades, achieving a PRE of 27 versus the international minimum of just 23, thanks to ensuring the optimal chemistry of chrome, nickel, and molybdenum. And here, if we take 5 popular Alleima grades, including SAF 2507 Super Duplex and higher alloy Synechro 28, you can see how Alleima PRE values exceed the international standard. In our finishing operations, we take extensive measures to ensure you always get ultra-clean hydraulic instrumentation tubing. Our aim is to ensure safe and trouble-free operation with every tube delivered. That is why we use a comprehensive 9-step cleaning process, from flushing with alkaline baths to drying, bright annealing, polishing, and finally, adding protective plugging. To sum up, clean hydraulic and instrumentation tubing means that you get reduced risk of system failure or unplanned maintenance, prevention against malfunctioning valves and actuators, and an inside surface free of scale and contamination. But how do we perform on bending and fitting? The secret lies in controlled hardness, which allows for easy bending and leak-free connections. Whatever the standard, our grades are always optimized to ensure easy, reliable bending, consistent quality for automated bending, no wall collapse, no cracks, and less use of power. Optimized hardness also ensures you get a vacuum-tight grip of the ferrule in the connection, preventing leaks and assuring consistent pressure and flow. Consistent ovality and tight tolerances set Alleima tubing apart and help prevent the risk of leaks. Our outer diameter tolerance often far exceeds the ASTM requirements. For example, For A269 category ASTM grades like 316 and 316L, the requirement is plus or minus 0.13 millimeters, whereas we consistently deliver plus or minus 0.08 millimeters with every batch. Naturally, a key benefit of our tight dimensional tolerance is a perfect leak-free connection. To sum up, we at Alleima always strive to set a higher standard within the standard, leading to safe, trouble-free operation, extended lifetime of equipment and systems, higher productivity, industry-leading sustainability and circularity, all of which ultimately results in greater peace of mind for our customers.
So we supply clean tube with very low hardness when it comes for hydraulic and instrumentation tube. We can supply the tube below 85 HRB hardness, which is very crucial. When you bend the tube, you'll find no crack and no leak in the tube. So some of the applications globally used by various customers, and we have a lot of references along this. Alleima 2RE10, which is the grade used for nitric acid application, and a lot of the licensors recommend this grade. And here within India, those companies who are manufacturing nitric acid plant, they are getting life of 32 years. We have the reference list. You can cross-check with them the life of the equipment. Then SAN 35 is the new alloy, what you will hear from our colleagues. This alloy is developed to fit the gap between austenitic steel and high nickel alloys, like C22, C276, where you don't have a choice to go for high nickel alloys. There we fit in, and this is the invention done by us to bring the cost down without compromising life and properties of the equipment. Another grade is the SX, which is used for sulfuric acid application, and it gives excellent life when it comes the concentration of sulfuric acid. Concentration of sulfuric acid is more than 98%. Of course, you'll hear more alloys. One of the alloys is bimetallic alloys, which is recommended by many of the licenses in fertilizer complex for urea stripper, which gives a highest life of 35 years. In one of the German plant within India, we have recorded life of 31 years in one of the plant. And then some of the new alloys, of course, my colleague will talk about it. And thank you very much. And we have done many failure analysis cases, around more than 300 cases. Some of the sample we have displayed, how tube fails. Of course, these are not our tube. These are supplied by industry, and we have local R&D where we do a lot of investigation on failure, why it has happened. And we have displayed some of them. You can check with our team about this. And thank you very much for listening.